Audio Jungle. Audio Jungle.
Hello everyone, myself Narendra Singh Maurya. Guys, today we'll solve GATE 2016 jet propulsion problem. Alright, so here we have problem number 6. For a completely subsonic isentropic flow through a convergent nozzle, which of the following statement is true? Okay, so here they have said that case a convergent nozzle. Okay, convergent nozzle. Check. Alright. A convergent nozzle, and it is completely isentropic flow. Okay, and isentropic flow means there is no losses in the nozzle. All right, and obviously it is completely subsonic, so whatever the flow here we have, it is subsonic only. So like, what maximum Mach number at exit? Okay, maximum Mach number at exit of nozzle. Here, what will be the maximum Mach number? That is equal to 1. All right. Maximum, I'm saying maximum is what? 1, and it is a subsonic isentropic flow, completely subsonic isentropic flow through a convergent nozzle. All right, so we have a convergent nozzle we have here, and maximum Mach number at exit can occurs 1. Okay, so what will be the relation? What statement is correct? Pressure at the nozzle exit is greater than back pressure. Pressure at the nozzle exit less than back pressure. Pressure at the nozzle exit is equal to back pressure. Pressure at the nozzle exit is equal to total pressure. Okay, this is the option they have given. Now, so in this case, if you check, basically, if you see this pressure at exit, okay, I must say pressure at exit is PE, back pressure or ambient pressure, which is nothing but I must say PB. Okay, so in this subsonic nozzle, see, this is what subsonic nozzle. All right, subsonic nozzle means m is equal to 1, m less than 1, and maximum Mach number at exit can occur, which is nothing but m is 1 maximum. This is subsonic nozzle. Okay, this is what subsonic nozzle. So at the exit of the nozzle, pressure is nothing but PE. Okay, and here this is the surrounding, so here pressure we have PB. So they are asking the condition. Okay, pressure at nozzle exit which means PE greater than PB. Okay, PE less than PB, PE is equal to PB, PE is equal to P naught they have given. Now, so PE greater than PB means exit pressure is what greater than PB. Then what is the mean of it? Okay, what is the mean of it? So if you check this case, when exit pressure is greater than PB pressure, this is called under expansion. What it is called? Under expansion case. Okay, and PE less than PB, this is called over expansion. Okay, and PE is equal to PB, this is called fully expansion or ideal expansion, or it is also a condition which is called choked condition. So obviously choked condition when m becomes 1, m is equal to 1. All right, then it will be called choked condition. So basically, when you will talk about the full expansion or ideal expansion, because it is subsonic flow, because if you go for the under expansion, so here in case of under expansion, you may get expansion fan. Okay, over expansion, you may get oblique shock. Okay, so this happens when flow is what greater than 1, or when flow is what supersonic flow. Basically it happens in city nozzle. But in case of the subsonic nozzle, as I said, maximum Mach number is what 1 at exit. So it is a subsonic nozzle. So maximum Mach number becomes 1, hence it can be choked condition, which is also called fully expansion or ideal expansion. So what is the correct answer for this? PE is equal to PB, means exit pressure is equal to back pressure or ambient pressure. Okay, so what is the answer? Hope you understood this. What is the answer here? Option C. No, simple answer is what? C. All right, because first two cases, PE greater than PB or PE less than PB, is not possible. Okay, both are not possible. As I said, it is like a basically formation of expansion fan or formation of the oblique shock, which is the case of the supersonic flow, m greater than 1. But this is the subsonic nozzle. Okay, this is the subsonic nozzle. So obviously flow maximum at the exit of the nozzle, flow maximum will be m is equal to 1. So there is no possibility to achieve supersonic flow inside the nozzle. Okay, so there is no chance for the formation of expansion fan or formation of oblique shock. There is no chance. Maximum is what? 1 Mach number, and Mach 1 called a choked condition of the nozzle. Okay, so that is also called ideal expansion or fully expansion or optimal expansion, or I will write optimal expansion. These are the term they are using many times, which means PE is equal to PB. All right, hope you understood. Thank you. Next. Okay, now this is the next question. So again, GATE 2016. Okay. Now this is problem number 7. Which one, which of the following aircraft engine has the highest propulsive efficiency at a cruising Mach number of less than 0.5? Okay. Mach number they have given how much? Less than 0.5, which means it is subsonic. Which means it is subsonic flow. All right. They are asking what is the highest propulsive efficiency. Now, so propulsive efficiency, as I already explained, like for the previous year problem also, it is nothing but thrust power. Okay, it is nothing but thrust power divided by the input, which is nothing but output divided by input. So input will be what? Thrust power plus loss. That will be the propulsive efficiency. Yes or no? This will be output here. Okay, this is the output, and this is what? Input. That input is equal to output plus loss. All right, that is called unutilized kinetic energy. So what is the loss? This loss is what? Unutilized kinetic energy in nozzle during expansion. So here you got eta p is directly proportional to thrust power. Thrust power more, that eta p means propulsive efficiency will be more. Okay, and remember this is the condition where one particular range they have given, that Mach number which is less than 0.5. So for the less than 0.5 Mach number, they are asking propulsive efficiency. That option is turbofan engine, turbojet engine, turboprop engine, and ramjet engine. So obviously ramjet is the basically engine which works for supersonic flow. So option D is completely wrong, no doubt about it. Okay. Turbojet is most of time it is suitable for very high speed Mach number, like maybe supersonic or some subsonic, or you can say like Mach number 0.8, 0.9, 1.2, or 2, 3. For supersonic also turbojet engine works properly. Okay, so this will not correct, because they have said Mach number is very less, means velocity is very less. What is the thrust? What is the thrust power? It is thrust into velocity. What is the thrust? Simple formula I will write: m dot a ve minus v infinity. Pressure thrust I have removed. So from here also, see, if it is not very high speed aircraft, so it means ve, which is nothing but exit velocity, which is ve, is what? Less, because the exhaust velocity is less, so obviously thrust will be less. And why exhaust velocity less? It is mentioned it is very uh, like a slow speed aircraft, less than 0.5 Mach number means slow speed aircraft, means exit velocity is what? Less. Yes or no? So if exit velocity is less, it means thrust will be less. Thrust will be less. Correct. At the same time, here, because Turbojet will also be not correct. Okay. Now we'll have a option turbofan and turboprop. Turbofan engine, that also most of time it works for zero point 0.8 Mach number or up to supersonic also 1.2, 1.4, 1.5 lower altitude aircraft. Coming to turboprop, this engine, whatever the thrust you are getting for this turbo engine, for 80% you are getting cold air and 20% you are getting for hot air. Because if you check the turboprop, so most of the thrust you may get from the propeller only. Okay, which is not relates to the, you know, like exhaust velocity of the nozzle. Okay, so in this situation, if Mach number is very less, then propulsive efficiency will be highest for the turboprop engine. Okay, because in fact turbofan engine also works for very high speed, uh, high Mach number. Okay, like I told you, 0.8, 1.2, 1.5, 4, 1.5, 1, 1.8, 2 Mach number. More than that you will go for turbojet. So what is the correct answer? Appropriate. So this is not like we have you know data to calculate some value. No, it is not. So you have to analyze by your own. I mean, based on the given data, step by step, if you analyze, then you may get that correct answer. So as I told you, here turboprop, among all four, turboprop is the engine which will get for this particular Mach number less than zero point 0.5, highest propulsive efficiency you may get in turboprop engine, because turbofan is also suitable Mach number like 0 0.8, 1, 1.2, 1.4, 1.5, and turbojet obviously it is more than turbofan, and ramjet is more than turbojet. So here turboprop is the appropriate answer for this particular Mach number. All right. What is the correct answer? Answer is C. All right. Answer is C. Okay. Next. Problem number 19. Combustion in gas turbine engine is ideally represented as following process. Okay. Now, combustion in a gas turbine engine is ideally represented as the following process. So, combustion they are asking for the turbine engine. Turbine engine means what? Brayton cycle. Hmm? So, we'll draw Brayton cycle. Okay. For the Brayton engine, we'll draw Brayton cycle. What is the Brayton cycle? Two reversible adiabatic process and two reversible isobaric process. Okay, so here check, this is the symbolic diagram for the gas turbine engine. Check. Okay, this is what? Compressor. This is combustion chamber here, and this is what? Turbine. This is what? Exit. VE, and this is what? V infinity. So if you draw the ideal Brayton cycle, okay, this is what the PV plot. This is what? TS plot. 1 to 2, you just say this is what A, this is 1, this is 2, okay, 2 to 3, 3 to 4, and this is what? So I'm drawing 1 to 2 compressor for the compressor. So this is 1 to 2 uh, wet. Must start from this end, so it will be better. Uh, 1 to 2. So what is 1 to 2? Check. 1 to 2 is the compression. Compression means pressure increasing and volume is decreasing. 2 to 3, at constant pressure we are adding heat. Okay, and 2 to 3 again expansion, which is nothing but 3 to 4 again expansion, which is nothing but turbine. This is what expansion. This is what compression. You all know this. Okay, and here this is the heat rejection, heat addition and heat rejection. 1 to 2 is the isentropic compression. So 1 to 2 isentropic compression. 2 to 3, this is the constant pressure line where you are adding heat. Okay, and here you are rejecting heat. You are adding heat, hence temperature is what increasing. You are rejecting it here. 4 to 1, hence temperature is what decreasing, and 3 to 4 is isentropic expansion. Okay, this is what turbine. This is what compressor. All right. So basically combustion means what? Heat addition. So both PV and TS plot you can check. Combustion means heat addition. Heat addition is what you are getting at constant pressure. So adiabatic is the isentropic, like heat constant. Isentropic means entropy constant. Isobaric means pressure constant. Isochoric means volume constant. So combustion means heat addition, and heat addition here you can check, this is what? Constant pressure. Yes or no? This is the constant pressure heat addition. Check. This is the constant pressure line, which is nothing but P is equal to C. This is PV plot. You can check. This is the constant pressure. So what is your correct answer? P constant means isobaric. So here your answer is option P. All right. Now we'll go for next question. An unmixed, this is problem number 26, an unmixed turbofan engine with bypass ratio of 6 flies with velocity of 200 meter per second. The core and the bypass nozzle of the engine, that are both conversion nozzle, okay, conversion nozzle, operates under choked condition and have exhaust static temperature 580 Kelvin and 295 Kelvin respectively. The specific gas constant and ratio of specific heat of both streams are 287 joule per kg Kelvin, 1.4 respectively. If the fuel air ratio is negligible, the thrust per unit mass flow rate generated by the engine. So they are asking thrust per unit mass, means specific thrust. Okay. We'll write given data. Bypass ratio means beta, which is nothing but m dot c divided by m dot h. M dot c means m dot cold air, hot air, with velocity of 200 meter per second. So here it is given V infinity, or you can say Vi, how much? 200 meter per second. Okay. The core and bypass nozzle both are convergent nozzle, operates under choked condition and have exhaust static temperature. This is the static temperature. So first core, T core exit means, they are saying core means hot exit. How much it is? 580 Kelvin, and bypass nozzle. T bypass exit, or T you can say cold. T cold exit how much? 295 Kelvin. They have said choked. Okay, what is the choked nozzle condition? Choked nozzle means exit pressure is equal to atmospheric pressure or back pressure. So it relates pressure thrust. Pressure thrust will be 0. That's the mean of it. Pressure thrust will be 0 because it is choked nozzle. All right. Now, so I must say this is what fan. Okay, and so whatever the air we are getting, this is the m dot a. Few parts will go in this nozzle, which is nothing but cold nozzle, and few parts of the air will go this side, convergent. Okay, nozzle, and at the same time few parts of the air will go in this core also. Okay, so here we have a mixing of the flow. Here we have a mixing of the flow. All right. Anyway, this is what fan. Okay, this is the compressor, which is called HPC, high pressure compressor. This is the high pressure turbine, and this is the low pressure turbine. And this fan is called low pressure compressor. Generic diagram I have drawn. So here, whatever the flow rate you are getting, this is called M dot C, which is means cold. And here, this is called M dot 4, means M dot H. Okay. So now we'll solve this problem. So they have said bypass ratio, they have given how much it is. It is 6. No? It is nothing but beta 6.0. Velocity they have given. Okay. And they have mentioned one more thing. If the fuel air ratio is negligible, they said. What is the fuel air ratio? Obviously, fuel will be injected in uh, uh, fuel air ratio means m dot f by m dot a, air. Okay, and air is nothing but, because fuel is what injected in, this core passage. This is called core passage. This is called core. Hot nozzle or hot passage called core. Okay, so always fuel will be injected in core. So in core, what is the mass flow rate? It is mass flow rate of the air, that is m dot h. So m dot f by m dot h is nothing but, they said negligible means zero. This is given zero. All right, now we'll proceed this problem. They are asking what is the thrust per unit mass. So we all know what is the thrust. It is nothing but momentum thrust plus pressure thrust. So this pressure thrust will be zero. Why? Because it is choked nozzle, which means PE is equal to PA or PB, back pressure. So you will have momentum thrust. What will be the momentum thrust? You can say thrust due to cold nozzle plus thrust due to hot nozzle or core nozzle. No? What is the cold nozzle thrust? It is, because fuel air ratio they have said it is negligible. Obviously in cold there is no fuel, so you can write m dot c cold air into V exit of cold air minus V infinity. Similarly, plus hot. Okay, m dot air. Okay, air means it is the hot air, right? Because in a hot nozzle it is m dot h. M dot h, in bracket you can write 1 plus f into V exit in hot nozzle minus V infinity. But this fuel air ratio is what? Negligible, they have said. Fuel air ratio you will write in hot nozzle, but it is negligible, so you can remove. Now m dot c V exit cold minus V infinity plus m dot h. If you want, you can do one thing. You know what is the beta? M dot c divided by m dot h. So if you want, you can convert that. What conversion you can write? I mean, m dot c and m dot h you have, so you can convert this part. You can write this for in one format. You can write maybe in m dot c format or in terms of m dot h format. It depends. It's your choice only. You can write in that format. Okay. So here, what we'll do, like if you write what is the m dot c or m dot h. So I will write m dot c. What will be the m dot c? M dot c will be 6 m dot h. You can write this format. Yes or no? Because they have given the bypass ratio, and bypass ratio is nothing but cold mass flow rate divided by hot mass flow rate. Hot mass flow rate. Okay. Now, so here we will write this m dot h. Next line, one more line need to write. No problem, we'll write VE hot minus V infinity. So we can write, because thrust we are interesting to write uh, like specific thrust we are interested to write thrust divided by mass flow rate. Okay, so that mass flow rate we can here write m dot c, which is nothing but 6 m dot h. Okay, so we can write 6 m dot h VE exit of cold minus V infinity plus m dot h. Now it is fine because all quantity I have converted in one mass flow rate. In fact, if you write this in terms of m dot c also, okay, okay. They are asking the flow rate generated by the engine. So engine means you will talk about, because through the engine means compressor turbine combustion chamber. So through the compressor turbine combustion chamber, what is the air? M dot h. So if you talk about thrust per unit mass, so it means thrust divided by m dot h. That's the mean of it, because in engine hot air you have. Okay, so that's the reason you can take, means whatever your replacement you are writing, it is correct. If they are saying per, bypass, so the m dot c will be divided. Okay, so m dot h you can replace. So here whatever you have done, it is okay. I mean, you can take common. So here thrust divide by m dot h you can write, which is nothing but specific thrust. Now you take common m dot h, so 6 VE cold minus V infinity, okay, plus VE hot minus in. Okay, m dot h you have taken this side. So now your specific thrust, I must write here once again, T divided by m dot h hot air 6 check. This is the value. So V exit hot air, V V infinity they have given, because V infinity is the aircraft speed, it is given how much? 270 meter per second it is given. Okay, this V infinity, because for both hot and cold this value will be same, because V infinity is what? Aircraft speed. What is the unknown? Unknown is VE exit velocity of the cold and V exit velocity of the hot. It is unknown. That we have to find. That we have to find. So check how you can find. It's very simple, because other quantity they have given, temperature they have given, exhaust, okay, both hot and cold. See that core temperature means hot nozzle temperature they have given static, okay, and cold bypass means cold exit temperature they have given. So with the help of this temperature we can calculate the uh, exit velocity at hot nozzle and cool nozzle. One more thing they have given, under choked condition. So choked condition, that condition we have to apply. Okay, here we can write if both, they said both nozzles are, if both nozzles are choked. What do you mean by choked condition? That choked condition I told you, it is P exit is equal to PB is equal to PA. That's the mean of it, ambient pressure, no? And if it is choked condition, then we can apply the choked condition. What is the choked condition? T naught exit divided by TE. Okay, or now TE you can say TC, because if it is choked then it is a critical condition, because choked means what? Mach number 1. If Mach number 1, then this is also related to critical condition. Critical condition. This is called critical condition. Okay, critical condition. So T naught E by, now you can static, you can say TC. Okay, this value will be TE or TC, it's your choice to write, because that meaning will be same. So this value will be 1 plus gamma minus 1 by 2 m square, but this m is what? 1, because it is choked. Choked means critical. Critical means Mach 1. So now T naught exit divided by TE, you can say 1 plus gamma minus 1 by 2, m becomes 1. Hence it is gamma plus 1 by, what is the gamma they have given? Check. I think they have given gamma, right? How much? 1.4. So we'll write this 1.4 plus 1 divided by 2. How much? 2.4 divided by 2, 1.2. So what will be the T naught E? T naught E will be 1.2 into TE. Okay. Now check. So we'll have T naught E is equal to 1.2 into TE. So we can write for core nozzle. Core nozzle means or hot nozzle. No? Core means hot nozzle. T naught E, we can write hot is equal to 1.2 TE hot. 1.2 into TE hot, it is given how much? Check. TE hot is 580 Kelvin. 580 Kelvin. How much? So this is 1.2 into 580. It's 696. I'm getting. Similarly, for bypass nozzle or nozzle, T naught E 1.2 T exit cold, because static exit temperature for the cooled nozzle they have given 1.2. What is the static temperature? I think 295, right? Check 295. So they have given 295. We'll calculate this. How much? 1.2 into 295. No? It is 354 Kelvin. All right. Now, both value we know that. Okay. What are the values we have now? We have T naught E hot 696 Kelvin. We have TE hot, which is nothing but 580 Kelvin. So similarly, we have T naught E cold, which is nothing but 354 Kelvin. We have TE cold, which is nothing but 295. So you know that total temperature and static temperature if we have, then we can calculate velocity. What is the total temperature? Total temperature is T naught is equal to static temperature plus V divided by V square divided by 2 Cp. This is the generic formula. You know that. Total enthalpy H naught is equal to H plus V square by 2. Same. So you convert it. You know that, no? So from this relation, what we can get? We can say V for the hot nozzle or VE for core. That will be, you calculate VE is nothing but T naught E for hot minus TE for hot into 2 Cp. Yes, we can calculate. 2 into Cp they have given, I think, check. Cp they have not given, but Cp we can calculate. What is the Cp? I will write here. Cp is what? Gamma R upon gamma minus 1. Gamma they have given 1.4, R they have given 287 divided by 1.4 minus 1. So it is nothing but 1.4 into 287 divided by 0.4 is 1.004 kilojoule per second. So you can write 1004, better, right? T naught E, just now you have seen how much? 696. minus how much? 580. So what is this value will be 2 into 1004.5, okay, into 696 minus 580. We'll take root of it. This is 482. 482.7 meter per second. This is nothing but V exit. Okay. Similarly, we can find V E for cold. So it is nothing but 2 Cp T naught E for cold minus T for hot. Okay. So VE cold is nothing but 2 1004 T naught E. What is the T naught E cooled? It is 354. It is, so we calculate this value is 2 into 1004, okay, in bracket 354 minus 295, and if you take root of it, you may get 344. How much? 344.19 meter per second. 9. This is now. So that value we got. Now what we'll do? We'll write a specific thrust. See, this is the specific thrust Fs here. This is the specific thrust, right? So we can write here Fs, specific thrust, which is nothing but 6 into VE cooled minus V cooled plus V exit hot minus, okay, sorry, this is the infinity, minus V infinity. Okay, so we can calculate Fs. Let me write this. VE is nothing but 344 minus, what is the value here? 344.19 minus this value is, I think, 270. Let me check. 200, sorry, it's a 200, no? All right, we'll write here 200 plus VE hot. How much? VE hot 482 minus V infinity. So now we'll calculate this. So minus 200, okay, into 6 plus in bracket 482 minus 200. It is 1147. I am getting Fs 1147.18 force thrust per unit mass, Newton per mass, so kg per second. Okay, or you can write 1147.18 Newton second per kg. Check, this was the fill in the blank, so I will write here. This is nothing but 1147 7.18. Done. Hope you all understand steps by steps I have solved here. So I think it is clear to all. All right. So like and subscribe the channel. Thank you all. Thank you so much.